Well, if you notice a big empty space right here, you're right. That's where the subwoofer goes. It's been acting up periodically, so I took a chance and shotgunned some parts in it, so we'll see how that goes. Got the subwoofer here on the bench. Cat's going to do a CAT scan on it. So I did a repair on this a couple years ago. It is a Sony SA-WM 500, and it had intermittent distorted audio, and it would power off. And I'm pretty sure I determined that it was the line in out jacks had broken loose off of the circuit board, but I don't think it's that issue anymore, because after it warms up, it wants to randomly like thunk and pop, and it's definitely a much higher frequency than the low pass filter should allow. So I'm going to go ahead and pull this thing apart, see what we can get in here, figure out what might be going on. I don't think it's the speaker itself, other than the cat trying to scratch it. It moves very freely. There's no damage to the foam. It's intact. I believe this one actually has a rubber surround, so I don't need to worry about the foam failing. But yeah, the cat has definitely scratched it. And then she's been using this as a scratching post as well. She's looking at it. It's like, hey, Daddy, that's mine. Why are you taking that away? So anyhow, I shotgunned and ordered a new STK404-140 that I'm just going to shotgun into it and see if that makes any kind of a difference. So let's get started and pull this thing apart. Okay, well, I got it opened up, and there is the STK404-140S. Now, the one I ordered is just a 404-140, but I can't find any difference in the schematic whatsoever, so I think it's going to work. The layout looks exactly the same. All I know is this thing is covered in cat hair and probably a little bit of dog hair, because we have dogs and cats. But take a look at those main filter caps. Those are 10,000 microfarad, 71 volt, I do believe. Yes, 10,000 at 71. I may want to look at replacing those. I'm not sure. However, I'm going to go ahead and ESR all the capacitors. You can kind of see a couple of them up in there. I'll go ahead and check the standby board as well. And I want to go ahead and look at the crossover control board, just take a peek at those caps, and especially to make sure those pots are actually soldered good. Because this thing is probably about 15 years old now. And like I said, I did have issues with it a few years ago. I did do a video on it, and I'll try to link it in the description or put a card up somewhere. And I know I soldered the STK chip right there, and I do believe that the problem was bad solder connections on these line input jacks. Anyhow, let's go ahead and pull this thing apart and check all the caps and see where that leads. Okay, so much like on the Miller and Cressels that you've seen me service so often in the past, you can remove, well, this is the hot plate on this unit. It does have one cable that connects to the power switch. The AC cord connects right here. And then there's another little 3-leaded cable that does connect right here. I think that's just for the front panel LED red-green indication as to whether the unit is powered up or not. So basically, yeah, if you have one of these and you needed service and you wanted me to service it, you could send this whole piece to me and I could service it. So I'm going to start by just tearing this thing apart. I want to get to the board that lies underneath right here. I want to get to the bottom of this board, which I think I can probably do without having to take this bracket off, just removing these two nuts that hold the shafts in place. So yeah, let's go ahead and start tearing this thing apart and see where we can get. Now, with any luck, this will just lift up and completely out of the way. So I want to go ahead and remove this frame from it right here. And I do see there are 2 screws in the circuit board, so we'll go ahead and pop those out. Let me get the rest of this out of the way. All right, so there is the preamplifier and power supply board. I just want to go ahead and check all the capacitors just to be safe. So these big caps look like they're possibly United Chemicon. That might be their logo. I'm not 100% sure, but what about these little caps? Who makes these guys? Okay, so both of those are Rubicon caps. And what's going on with this resistor right there? Possibly a manufacturing defect. I don't think it's blown out. I don't like these little tiny caps. I don't know why they can't use regular size caps. That's an Elna. I believe it's a 10 at 35. Yes, those are Elna's, ELNA, 10 at 35. And then I thought I saw a Lelon cap actually in this thing a little bit ago. But let's go ahead and I'll mark these like I normally do, and we'll just go ahead and check them. I'm pretty sure the problem last time was these solder connections right there just broke free. One of the reasons they break free is because they went ahead and added some Silastic to these terminals, which causes them not to move freely with the board. It causes them to fight as it heats up and cools down. So that's one of the issues. Anytime I see something glued down, I suspect that might be the problem, especially when they glue down heat sinks and whatnot. It does tend to have them break free over time. Okay, here we go. Let's go ahead and check some caps. So these two are going to be 10s at 35. I see 2.6 ohms and 2.6. That's pretty good for a 10. This one is a 330 at 35 volts. I see 0.16. I'm perfectly happy with that. This one is a 22 at 25 volts. I see 0.85 ohms. I'm pretty happy with that. This one is a 330 at 16 volts. I see 0.2 ohms. Pretty good. This one is a 2.2 and I see 6.7 ohms. That one's okay. Here is a 220 at 10 volts. I see 0.56 ohms. This one is a 10 at 35 volts, 2.5 ohms. Another 10 at 35, 3 ohms. These are 10s at 50, 1.6 ohms and 1.5 ohms. I'm okay with those. These are 10,000s, 0.01, 0.02. I'd like to see 0.0. Let's make sure. Yep, our leads are good. And then this one also, 0.02, 0.03. Once again, check the lead integrity, 0.0. And there we go, 0.01, 0.02. I think I'm probably going to let those slide. These last two are 220s at 25 volts. So I've got 0.22 ohms and 0.23 ohms. I think those are all going to be okay. So every capacitor on that board checks perfectly fine. Let's move on to the base level. Okay, so this is the little low pass filter and base level as well as phase. You can actually switch this switch and control the phase 180 degrees. So the first one we're going to be looking at is a 4.7 at 50 and I'm seeing 1.5. I'm good with that. The next one is a 22 at 50, 0.9. Perfectly happy with that. This one is another 22 at 50. Once again, 0.9 ohms, good with that. And last, a 4.7 at 50, and I've got 1.6. So far, every capacitor in this unit is testing absolutely perfectly. I really thought after 15 years of fairly intense use, some of these things would be bad by now. All right, next on to the power amplifier board. Right off the bat, I don't like the footprint on the STK chip. It has a big gap right here that never really had any heatsink compound under it. So that could be a problem, especially if that's where the output transistors actually are. Okay, before replacing the chip on the power amplifier board, let's go ahead and check all of these caps as well. So over here, we'll start with a 10 at 100 volts. 0.93 ohms, I'm good with that. This is a 47 at 100 volts. I'd like to see probably half an ohm or less, and I see 0.3. This one is a 10 at 100 volts. 1 ohm, this one was a 10 at 100 also, and I got 0.93. Pretty doggone close. This one is a 100 at 25. Once again, half an ohm or less. Oh, that one's 0.7. I may end up changing that one cap. This one is a 100 at 100 volts. 0.13, I'm very good with that. And this one is a 220 at 25 volts. 0.3, just a hair high for my liking, but it's not out of the ballpark. This is a 10 at 50, 1.4 ohms. Well, the only ones I'm really concerned with are the 100 at 25 because I'd like to see half an ohm or less on that. And the 220 at 25, I'd kind of like to see quarter ohm or less. It's really doggone close though, really close. So I think at this point, I'm just going to let these things slide because they're not really that far out of the ballpark, like I said. Let's go ahead and slap the new STK chip into this thing, put it back together, and hopefully that takes care of the problem that I've been having. Okay, well, the old STK chip is out. Every lead came out perfectly, no damage to the board whatsoever. So I'm not going to solder this in until I have it mounted to the heatsink, so that way it does not have any extra stress from pushing or pulling. Okay, so I have the new chip sitting here, and I just want to make sure that it moves very freely. I do have it inserted into the holes. I want no stress on this after it's soldered whatsoever. So next, I need to go ahead and add some fresh heatsink compound to the bottom of it and make sure it has a good footprint to the heatsink. So I've got a brand new tube of Super Lube silicone heatsink compound dielectric. We're going to give this a try. I've never tried this before. I just ordered it from Amazon. So 3 ounces. We're just going to go ahead and squeeze a good amount out. And I'm just going to go ahead and coat the whole back side of the chip with it. Now if this works, it'll just squeeze out once I mount it to the heatsink, and everything will be perfectly fine. So next I'm just going to go ahead and place the chip in place. I'm going to give it just a small amount of downward pressure and rotate it, and then lift it up and take a look at the footprint, and that looks good. The back side of the chip looks good. So that's without any pressure applied to it. The screws aren't even in it yet. So let's go ahead and mount this thing. Okay, chip is all tightened up and ready to go. Let's go ahead and solder it up now. Okay, all soldered up. Let's throw this thing back together and give it a test. So there must be something different between the STK404-140 and the 404-140S, because when I connected this thing up, I got a terrible hum. But if I put my voltmeter on either pin 3 or pin 4 and added a bit of capacitance to it, the hum would totally go away and it worked perfectly. So I ended up hanging a couple of 2200 picofarad caps between pin 3 and ground that you can see right here, and pin 4 and ground. So I added a ring connector. I soldered the picofarad caps into the ring connector, and now the thing sounds absolutely perfect. So it's got to be some kind of a difference between the 140 and the 140S, and that's all I can come up with. The 140 seems to be a little more sensitive, and it had a really bad hum to it, but once again, once I added these caps to it, the hum totally went away. So everything sounds great now. So I'll power the unit on. Speaker relay closed, absolutely no hum whatsoever. So I'll connect my MP3 player to it real quickly. I have this thing laying on its face right now, so that's why it sounds like it does. If I lift it up a little bit, I get more bass out of it. And this is still loose. I haven't even attached it yet. So let me go ahead and put all the back screws on it and the little tune port, and we'll give it a final test. Well, there it is, back together. Let's go ahead and crank up some audio into it. There's quite a bit of audio. So no hum, no distortion, everything sounds great right now. That's it, the end of the video on the Sony SA-WM 500, replacing the STK404-140S with a non-S chip. Just had to add a couple capacitors for a little bit of bypassing. Everything's working great. Go ahead and leave me a question, a comment, a concern down below. Good or bad, I try to respond to the comments when I have time. While you're down there, hit that subscribe button and like this video. It really does help my channel grow. You can follow me on social media, Facebook, Instagram, Twitter at NorCal715. You can email me, NorCal715videos@gmail.com. That is the best way to contact me. I do have a full-time job, and I do this in my spare time. Please be patient. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everybody have a great day. Thank you so much for making it to the end of this video. I really do appreciate it. Once again, thank you so much for watching. Bye-bye.